Hi, welcome to my video series, Introduction to DORM. DORM is a dry object relational mapper. I guess I need to thinking whether I should change the name for it. All right, and in the last video, we looked at what a table is, what is its relationship with the queries, and we saw, I think, an associated query as well that generates for the sum. But let's talk about how we can actually fetch the data. So I have refactored my code a little bit. First of all, rather than users, we're now going to be selecting products because this is what is inside my PostgreSQL table. With name, description, and default price. This is how we currently generate the query. It will be much nicer, so there will be, I will actually show you what I'm planning to do with this, but for now this is how things are. So here we generating the select query, we're putting into the query variable, and then we're feeding that query into the Postgres, saying execute that query, and we're waiting for the results, and the potentially results can end up with an error, so we need to handle that error, and eventually we get a vector value, which is an array of array rows. Array of rows. And here we can iterate through the results. Let me actually do this first. All right, so dbg is a handy debug macro, so it's like var dump in PHP. Let's see what's going to happen with this. So you see we're iterating, and we have a row, which is a generic object, but generic objects, they're not really nice. First, if you do row, and you get a bunch of these like really weird things. If you wanted to access a specific variable like name, you can. All right, so now we have all the names. However, if you mistype that, you end up with nulls, right? So there are no type safety in this. However, what is quite common in Rust is defining a product struct. So this is a product struct. Name, description, default price. And then I have to mention that the price is currently string. Right now, everything is string. I haven't dealt with the types properly, but it will be implemented properly. And here what we do is we're converting the row inside the product. And then let me do the product here first. This wouldn't be much different, except that you see the type product. However, now you can do name like this, right? And it's much nicer. You have the types and you have the completion, so you interact with the names. And this is the entity. This is the entity struct. So this representing individual object. And potentially, we can also implement certain queries on top of that. Now, this here derives cert and deserialize. Cert, this one here, it's a very popular library in Rust, created in Rust, that allows you to convert arbitrary structures like this into a serialized storage like JSON and then back, right? Because the thing is that if you define it without that, this struct doesn't actually carry any information about what field, what are the name of the fields. However, with some macro magic and cert, it creates certain elements and it allows to map it into between different things. And because we already use values, so we use values when we pass stuff inside the query, and when we also receive, there's a bag of values, it is quite handy to take these values and then convert them into the desired product. So this is what is working right now. Let's talk about how we would like this to act and how I'm planning the syntax to be. So first of all, the product set is a table, right? I should be able to do load individual element like this, right? Product equals product set with ID, right? So this is already implemented. So this adds the condition for a specific ID, and you can pass the ID in. And then secondly, into product. Right? Or maybe it would be like load into. And then obviously we also need a wait, and it can throw an error. Maybe it will be load into, I'm not sure. But anyways, this is how we reduce the scope for the product set, and then we'll load into a specific type that we have defined, and then the type of this variable is going to be inferred to be product as well, and we can handle the error conditions, and this is an async operation as well, so it's not going to happen immediately. It's just going to asynchronously complete. Will fit inside here. Okay, so that's the syntactic sugar. That's thing number one I want to do. Next, we might want to iterate across the product sets. And there are several ways how we can do that. Actually, before that, let's talk about update. So I have this product now. Let's say it doesn't know what the type is. I'm just gonna say it explicitly. Okay, now product default price. Price equals string. So yeah, ignore the toString. Let's say I change the price and I want to save it back. So the way how I would save it would be product. The product set is no longer accessible, so we'll have to do clone here. And let's do another product set. Clone again. Now with ID. This is needed because the ID is not been stored inside the product. Product entity does not know what ID it is. We need that. I need to import the macro. Okay, so what this macro does is just you can pass certain things that can be converted into the JSON value, and it returns the JSON value here. Okay. And this is because I haven't decided what the ID should be. It's a numeric or it's non-numeric. If it's value, it can be anything, right? So it can be anything here. Anyway, so product set clone with ID, and then we do update product away. Yeah. So that would be the way how. So this is how we load. This is how we save stuff inside, right? So that, and if you forget that one, it's just gonna update a bunch of different things. Generate the update query. Okay. Now, next interesting thing I wanted to talk about. Let's say I'm going to product here and I'm going to comment out the description. All right, so product no longer have the description. We don't need that for whatever reason, but we still can use it with the product set. So even though the field description is declared here, when we are executing that load into, we can look inside the product and we could say, it doesn't have the descriptions. We're not going to query that. So we're only going to query to the name and default price. And the same thing here. So because that doesn't have that field, we don't need to update that field. So we only update the fields which are presented to us here, right? And that's kind of the high-level concept behind operating, converting the table sets, loading and accessing records. And oh yes, the other thing, this will be let id equals, so you can put it in here, and you can do insert, and you don't need that. This inserts the product and returns the ID, right? So ID would be value. So these are our CRUD operations, and this is how we can move between product, right? And this insert would be implemented for anything that implements deserialization, and this is quite handy, right? So this is really nice. Let's look at another thing. I'm going to comment this one out, and let's talk about iterating through things. First, let's say we want to take the product set. Now in Rust, there is a concept of called iterators. Let me show you how it works. Let example vec equals vec 1, 2, 3. Okay. Now this is array of 3 elements. Now I want to iterate over that. The way that is happening, so I could do for e in example vec. What's this? So this works, right? And then e becomes an integer. That's one way to iterate. But what if I wanted to kind of do this declarative mapping things, right? So what if I want to create a like another vector that contains all the values increased by 1? And there is the concept of iterator, right? Just gonna call it, and we can convert example vec into iterator. And the way that works, iter has this type, right? So no, it's rather than vector of that, we have iterator. An iterator will yield one value at a time, and I can go over that. But more importantly, it has a function called map, and we can provide a callback into this. This is how the callback works. So value v, I'm gonna be like v plus 5. This is how we can change. So this generates a new iterator, like that maps into the new iterator. Because I can also change the type of the items here, and it will become iterator of a different type. So for instance, I could do like that, right? And that becomes item becomes str. And finally, iterator can be collected, right? And this is the collection routine. So you have the iterator, you need to collect, and then you specify in what is the kind of structure you would like to collect it into. And I want to collect into vector back, and now I'm back with this array, and it has this new values now, right? So this is the previous one, Willy values. And this concept is very often used in Rust when you have something like a vector, and you iterate over that, and you collect it inside another vector. So first of all, how do we can adopt that to the product set? So product set, let right? So we need to have this iter, right? Iter method. So it's not implemented yet, we're planning to implement it. And this iter will create the iterator that goes over the entries of the product and then returns, this will be iterator item equals value. So that will be the type, right? Because value is arbitrary value of a row, and it's just gonna do that. Okay, that's cool. But then again, you know, we can, I suppose we could do something like that, and we have the product in here. I'll see what's possible, but I think that this is also should be okay. We can create iterator over a specific struct. Right, now in some cases we would like to update our database structure, and there's a really nice way how to do it, and that's map. So if we call map and we get the value here, so the v would be the value of a record, and it will automatically save the records back, overwriting the existing one. So now this is a little bit difficult because maybe like a value, and we need to do name, something names. I'm not sure how you can assign that, but let's say v name is surname, so one of this. So I want to copy surname into name, right? And this should be perfectly possible. Oh yes, we need to return v. Probably wrap this into. Okay, so this is anonymous function, right? That consists of two lines. The first one is some kind of assignment, and secondly, we're going to yield the new value, which is then going to be passed back to the map, and map will be saving back into our product set. Now, of course, it makes sure that the ID remains unchanged, and also will make sure that it's not going to be written outside of the product set scope. So you'll have the kind of necessary guardrails around it, or maybe it will. Yeah, maybe it will. Okay, let me talk about the next thing. So if we do map product, then in here v would become product. That means v name equals v surname. So this is much easier to manage when we're doing the mapping and we use our own custom struct to do the iteration. Okay, so that's another way how this is. So we can operate with the elements. Okay, I'll see you in the next video. I still have a lot of the interesting things to show, some of the plans, so I'll see you in the next video.